Hello everyone, and welcome to the Sustainable Sites category. Now it may help to think about sustainable sites in two basic ways. First we have site selection, and the other is site development. Now the location of a project, while it is specifically recognized in the location and transportation category, nonetheless drives many aspects of the sustainable sites category, especially with relation to the local bioregion, watershed, and community, and represents the foundation for the sustainability of individual buildings or even entire neighborhoods. Great site design can provide ecosystem services and create a sense of place. Site design also plays an important role in helping projects adapt to the effects of climate change. Site design begins with a comprehensive assessment of the site. Now, by exploring the site's best features and its challenges, the team can integrate the building and grounds into the local ecosystem. A site assessment identifies assets such as favorable climate conditions and potential solar access, as well as those liabilities such as unhealthy soils, blighted structures, pollution sources, and steep slopes. An assessment conducted before or during the conceptual design phase can help project teams reduce cost, reduce risk, promote occupant health, and promote the site's unique characteristics. After the site is chosen, the development of the site is really the next big step in achieving a sustainable project. Developing a master plan can help ensure that your initial environmental considerations are carried forward into future expansion or renovations. Planting sustainable landscapes and avoiding soil compaction have broad positive impacts. These practices help prevent soil erosion, clean stormwater and slow rainwater runoff, reduce heat island effect, restore habitat, and reduce irrigation demand. Thoughtful lighting of the site can create a safer nighttime environment while avoiding night sky pollution and saving energy. Taken as a whole, these types of site strategies not only enhance plant and wildlife habitat, but they also improve our air and our water quality and decrease energy costs. Now here we see the prerequisites we're going to tackle in this category. First we have construction activity pollution prevention. This prerequisite applies to all of the rating system adaptations. Then we have the environmental site assessment, which applies just to LEED for schools and LEED for healthcare. Regarding our credits, we have site assessment, site development, protect or restore habitat, open space, rainwater management, heat island reduction, and light pollution reduction. In addition to those base credits, we also have the site master plan for LEED for schools, tenant design and construction guidelines for core and shell, and then places of respite and direct exterior access, both just under the LEED for Healthcare program. Now here's our first prerequisite of the category. SS Prerequisite Construction Activity Pollution Prevention. The intent here is to reduce pollution from construction activities by controlling soil erosion, waterway sedimentation, and airborne dust. Now the requirements are pretty straightforward, so the project team needs to create and implement an erosion and sedimentation control plan, not only that it addresses the construction of the building itself, but also any demolition on the site. The plan must follow the EPA 2012 Construction General Permit or local equivalent, if that happens to be more stringent. There are several considerations for project teams when looking to implement an erosion sedimentation control plan. First off, keeping in mind what the ESC plan is intended to achieve. We've got topsoil protection, reduced sedimentation of receiving streams, and eliminating, or mitigating anyway, air pollution. Now something else to keep in mind, the EPA General Permit, according to its own criteria, applies to sites 1 acre in size or greater. Now LEED makes no such distinction, so a project site, even a very small project site, well under an acre, still has to implement the EPA General Permit as if it applied to that project. Now the control plan not only identifies the measures that are going to be implemented, but also provides adequate description so that the contractor can put those into place. There are two types of strategies that can be put into place. On one hand, we have stabilization controls, which are mulching, temporary seeding, and permanent seeding, or structural controls, which include silt fences, sediment basin, earthen dikes, and sediment traps. Now what we're seeing here is what not to do. On the left-hand side, we see a sediment trap. Now, these are valuable measures that can be put into place on a project, but this one is obviously not functioning correctly. And you can tell because the sediment that's supposed to be prevented from reaching that receiving grill has gone ahead and flown to it, and sooner or later that grill is going to get plugged up and cause what we see on the right-hand side, which is water backing up at the street level. Now here's a few better approaches, although imperfect in their own way. So on the left-hand side we see a silt fence. It's a classic example, and I wouldn't say there's anything obvious to call out that they're doing incorrectly there. But on the right-hand side we see stockpiled topsoil. That's a terrific strategy to maintain topsoil, which can be very expensive, and bringing in new topsoil has its own environmental impact. Now the strategy is great, but what they're not remembering in this example, or maybe they just haven't got around to putting it on yet, is that this soil is going to disappear the first time there's a significant windstorm or a rain event. It's just going to wash away. So it's critical that not only do you protect it from, say, vehicle or pedestrian traffic, but also that it's covered to protect it from the elements. And here's our first question of the category. Structural controls for erosion and sedimentation control. So select two of these that are structural controls for erosion and sedimentation control. Well, in this case, the correct answers are 2 and 4, sediment traps and silt fencing. Okay, so our next credit, SS credit site assessment, where the intent is to assess site conditions before design to evaluate sustainable options and inform related decisions about site design. The requirements here are that the project put into place a site survey. Now the site survey needs to look at a bunch of things. They look at topography, hydrology, climate, vegetation, soils, human use, and then any human health effects. Now critically here, the survey doesn't just need to take place in isolation. It also needs to demonstrate how these features have influenced the design itself. So a project team that does a site survey in isolation and then can't connect the dots between how that survey impacted the design probably won't be earning this credit. So it's important that you not only do the survey, but then you use that to improve the building itself. So the strategies to keep in mind here. First of all, early engagement is critical. Now once the building design begins to take form, it's a lot more difficult to change underlying major systems. So whether it's adjusting the heating and cooling system or a complete change in building orientation. If you get that information early on in the process, you're going to save a lot of rework and keep those doors open so that you can optimize the building performance. And here's our question. Performing a site assessment before conceptual design can help achieve all of the following except what? And the correct answer is number 3, increased participation in vehicle sharing services. So what this question shows is that performing a site assessment can contribute to each of these other 4 areas. So it can help reduce life cycle impacts, it can increase biodiversity, reduce costs for renewable energy systems, and overall reduce risk. Now the one on here that might not seem straightforward at first glance, reducing the cost for renewable energy, well that becomes a possibility because by identifying whether it's solar access, the availability of significant wind energy, maybe there's potential for tidal or geothermal energy on the site. And in doing that site assessment, you can help uncover some of those potential opportunities. Our next credit, SS credit site development, protect or restore habitat. Our intent is to conserve existing natural areas and restore damaged areas to provide habitat and promote biodiversity. Now there's 2 ways that projects can attempt this credit. But first of all projects, regardless of their option, need to protect at least 40% of any existing greenfield location on site. Now if there is no existing greenfield on the site, which is typical probably of any infill project or project locating in a dense urban environment, but for your rural projects or those moving on to undeveloped land, you're likely to have a lot of greenfield area. So once you've addressed that protection of the greenfield, then there's the 2 options. So first of all, on-site restoration. So projects that have some site to work with, if they restore 30% of the previously developed site, so that excludes the greenfield areas, so you're only dealing with what's left of the site, 30% of that restored using native or adapted vegetation and protecting soils can get you the 2 points here. Now, projects that may not want to pursue native or adapted vegetation, or those with very constrained sites, so maybe they don't have 30% of their previously developed site even available at this point. Maybe the building footprint takes up too much space. They have the opportunity to donate cash to a locally recognized land trust or conservation organization to the tune of 40 cents a square foot. And by taking this approach, they'll get 1 point. Now let's look at a couple of definitions. First of all, greenfield. This is an area that has not been graded, compacted, cleared, or disturbed, and that supports or could support open space, habitat, or natural hydrology. The other definition I want to talk about is development footprint. Now, this is a pretty simple idea, but it's really important from a LEED standpoint that we all mean the same thing when we say development footprint. Now, the development footprint is the total land area of a project site covered by buildings, streets, parking areas, and other typically impermeable surfaces constructed as part of the project. So there are a lot of strategies when looking at protecting and restoring habitat. Now, first of all, it's critical that you have a good list of native or adapted plantings that you can select from for your site. There are a lot of agencies, and they vary wildly by region in terms of who maintains these lists of native and adapted plantings. I know in my part of the world, the state university system, and actually one of the notable state universities, maintains a regional plantings list for the state. Now, there's another element here that introduces a new concept known as floor to area ratio. Now, floor to area ratio, sometimes abbreviated FAR or FAR, is the occupiable space of a building, so we're talking floor area, divided by the site area. So if it's a two-story development, and say it has a zero lot line, or the building takes up all of the site, you would have a 2.0 floor to area ratio. Now, if only half of your site's developed and it's only one story, you're going to have a 0.5 FAR. Now, why that matters is that projects that achieve a 1.5 floor to area ratio or higher can count their vegetated roof as on-site restoration. Now, the caveat being that it has to be planted with native or adapted plantings, but that opens the door for projects with small sites to potentially achieve this credit as well. Other types of areas may be optionally excluded at the discretion of the project team. So rain gardens or other vegetated landscape areas, depending on your bioregion, may be better served with a non-native, non-adapted plant because it has better qualities in terms of allowing infiltration of rainwater. Now, LEED doesn't want to preclude projects from using those non-native, non-adapted plantings if it makes sense for the project. So here they keep the door open for project teams to simply exempt these infiltration basins. There's also a couple of rules around what type of land trusts or other conservation organizations will be accepted. Now, in the US, the project needs to select a land trust organization that's been accredited by the Land Trust Alliance. For non-US projects, they must select an organization within 100 miles of the project. Now we look at land trust. This is a private nonprofit organization that all or part of its mission actively works to conserve land by undertaking or assisting in conservation easement or land acquisition, or by its stewardship of such land or easements. So here we see our first example of the category. Now, prior to development, this project site was partially developed and partially undeveloped, or greenfield. Now let's take a look at some of these calculations. And before we jump in, I want to stress that within the LEED Green Associate exam, they would not expect you to perform this type of calculation. The reason we take a little bit of time to do this here is not because we need candidates to memorize the calculation methodologies. It's really to reinforce the processes behind LEED. So while we do have several examples of calculations that we show within the scope of this course, I don't want anybody to get too concerned that they're going to be asked to perform calculations that include this much complexity within the scope of their exam. Well, with that said, let's take a look at what we've got. Now, our site area is 994,000 square feet. The previously developed portion of the site, which is most of it here, is 837,000. The previously developed area that has been restored is 326,000. So right there we have some numbers we can work with. 38.99 or 39 basically % of the project site that was previously developed has been restored. So from that perspective, when we're talking about the previously developed site, the project is meeting the requirements. We also need to take a look at the previously undeveloped portion of the site, where in this case we're conserving over 81%, which easily exceeds the 40% required by the credit. Based on this information, we know that if the project complies with the soils requirement as well, it'll meet the credit criteria. And now our question. Which of the following would help provide habitat to native wildlife? So go ahead and select 3. Okay, and our correct answers are 2, 3, and 4. Install a green roof using native plants, limit the area of construction disturbance around the building's footprint, and replace invasive species with native plants. Here's our next credit, SS Credit Open Space, where our intent is to create exterior open space that encourages interaction with the environment, social interaction, passive recreation, and physical activities. The requirement is not that complicated, but there's 2 layers to it. So first of all, the project needs to provide open and accessible space that's outdoors equal to at least 30% of the total site. Now 25% of this 30%, or put it another way, 7.5% of the site, needs to be open accessible outdoor space, but it also needs to be vegetated or under a vegetated canopy. Now in addition to all of that, the open space needs to meet one of these 5 criteria. So it needs to be pedestrian oriented. Now this can be paving or turf area and will include elements that accommodate social activities. It can also be recreation oriented, which again can be paving or turf area and will include elements that encourage physical activity. It can be garden space with year-round visual interest and diverse plantings. It can also be garden space that's dedicated to food production or that's used as community gardens. Or finally, it can be habitat that meets criteria of SS Credit Site Development, Protect or Restore Habitat, and includes elements of human interaction. So with that in mind, there's a lot of strategies that play into this credit as well. First of all, and you'll continue to hear it throughout this category, select a suitable building location. Now, the site selection obviously plays a huge role here in what the opportunities to accommodate open space goals are going to be. In addition to that, even once you have your site, there's some strategies that can help keep this open space protected so that it can be provided to the building users as open space. So stacking the building program, tucking the parking under the building, or even sharing amenities such as parking with neighboring buildings. Now turf grass is treated uniquely by this credit. It doesn't qualify as vegetated, at least for credit purposes. Obviously it technically would be vegetated, but not for LEED purposes here. Although it does qualify as open space. And the reason for that is they're trying to provide vegetated areas that can increase biodiversity. And turf grass plantings are among the worst performers in terms of vegetated plantings in how they foster biodiversity. Vegetated roof surfaces, much like in that last credit, can qualify here if the project achieves that 1.5 floor to area ratio. That's really the threshold that gives projects the opportunity to take credit for their vegetated roofs. Wetlands or naturally designed ponds can count here if the side slopes aren't too steep. And now finally, for campus projects, I typically think of a college campus, but keep in mind it can be an industrial campus or a commercial campus of any kind. Open space can be anywhere on the master site, as long as it's protected from development for the life of the LEED project. And here's our next example, same project that we looked at in our previous example. So we have a few points of information. We have that same 994,000 square feet. What that means is that 293,000 square feet of open space will be required, and of that, 74,000 and change needs to be vegetated. This project happens to be providing over 570,000 square feet of vegetated open space. So right there, that open space that happens to be vegetated meets both of these criteria independently, so the project is clearly compliant. And here's our question. Which of the following would not help increase the open space on a site? And the correct answer is planting only native plants. Now, while this represents a sustainability strategy, so we're not suggesting here that planting natives is not a good thing, because it is. It happens to have no impact, however, on the amount of open space that's ultimately provided to the building users. And our next credit is SS Credit Rainwater Management. where the intent is to reduce runoff volume and improve water quality by replicating the natural hydrology and water balance of the site. Now, this is based on historical conditions and undeveloped ecosystems in the region. There's 3 paths to option 1 here, and we'll talk about option 2 in a second. But the paths are based around achievement of a percentile of the rain events. So what I mean when I say that is, so for path 1, the project needs to manage runoff for the 95th percentile of regional or local rainfall events. Now, what that really means is that 19 out of 20 rainfall events, so not counting days when there's no rain, but when there's rain that day, 19 times out of 20, or 95% of the time, the project can infiltrate all that water on site. And it only goes to the backup system 5% or less of the time. Now, path 2 is the 98th percentile. Same requirements as the 95th, except it's a tighter threshold for compliance, and only 2% of those rainfall events will overflow into the backup system. Path 3 represents specific types of projects. So these are zero lot line projects. These projects achieve a minimum 1.5 floor to area ratio, and they're only required to manage the stormwater runoff for the 85th percentile. So this recognizes that projects with constrained sites, so those zero lot line projects, have more difficulty achieving successful rainwater management strategies because they have less site area to work with. And now option 2, really straightforward. Natural land cover conditions, so these are greenfield sites. The post-development runoff must not exceed the pre-development runoff. So you'll calculate the post-development runoff levels, also those pre-development runoff levels, compare the two, and as long as you're not providing more runoff than you were pre-development, you're going to meet the requirements here. Now, our strategies and terms are significant here as well. First of all, design the project to maintain natural flows. This can be by promoting infiltration or by studying adjacent sites to see how the water moves naturally. Vegetated roofs, pervious pavement, and there's other measures as well, can help minimize those impervious surfaces. Now, the impervious surfaces you'll typically encounter on an average building site are parking lots and drive aisles and the building roof. These strategies help to minimize the impact of those historically impermeable surfaces by allowing infiltration through them. And we'll look at a neat example here in just a moment. Now, stormwater reuse. We certainly understand that it's going to save a little water because you don't need to use potable water if you're using non-potable sources such as stormwater to meet certain types of needs. Now, you wouldn't want to drink it unless it was properly purified, but there's lots of uses such as toilet flushing, custodial uses, landscape irrigation, where non-potable sources may be appropriate. It also has that additional benefit, which is recognized here, by not only saving water, but also reducing the need and demands on the rainwater management system. So if you're reusing that water, that's water you don't have to infiltrate to your site. There's additional strategies such as dry ponds, bioswales, and rain gardens that can help manage stormwater. Finally, projects that are on a campus can meet these credit requirements using a coordinated approach and infiltrating the water somewhere else on campus. So it's often the case where you've got several buildings on a campus. They're going to be able to infiltrate more rainwater for less development dollars if they pool those resources and focus their efforts on a central system that serves several buildings all at the same time. And here's another definition that I think we need to cover. Low-impact development is an approach to managing rainwater runoff that emphasizes on-site natural features to protect water quality. They do this by replicating the natural land cover hydrologic regime of watersheds and addressing runoff close to its source. Examples include better site design principles, which is minimizing land disturbance, preserving vegetation, and minimizing impervious cover, and design practices such as rain gardens, vegetated swales and buffers, permeable pavement, rainwater harvesting, and soil amendments. These are engineered practices that likely require specialized design assistance. Here is a classic example of a low-impact development strategy. What we see on the bottom right is an open grid pavement system. Now, the gravel paving that you see on the left-hand side is actually embedded with this open grid pavement system. So what looks like just standard gravel is much, much more stable than your typical gravel, while still maintaining the permeability benefits that you get by a non-permanently paved surface. Which brings us to our next definition. Green infrastructure is a soil and vegetation-based approach to wet weather management that is cost-effective, sustainable, and environmentally friendly. Green infrastructure management approaches and technologies infiltrate, evapotranspirate, capture, and reuse stormwater to maintain or restore natural hydrologies. Now, what does that mean in practice? So green infrastructure strategies, which are replicated portions of natural hydrologic cycles, help the project integrate with the surrounding watershed, are suitable for the local environment, and provide ecosystem services such as water reuse, habitat creation, and species diversity. Considerations include how can green infrastructure and low-impact development best mimic natural site hydrology, and how a treatment train, which are several sequential measures, can work together most effectively. Existing soil conditions also may determine how these can be appropriately implemented on site. Now we'll hear from sustainability design expert Heather DeGrella as she discusses selecting a proper building site.
I had the great privilege of working on a headquarters for the World Birding Center in Mission in the Rio Grande Valley of Texas. And the site selection for this was a really intense, thoughtful process where we brought together a whole bunch of experts, a biologist, the architect, the landscape architect, land planners, the community, to really choose a site thoughtfully. And so what we chose was some previously developed land, would be the correct term. What this was farmed land. And next to it, 1,700 acres of preserve that had actually not been disturbed by the detrimental process of farming. And so the building is actually located on the previously developed land. It does two things. It takes the opportunity to repair the land, and it also takes the opportunity to educate everyone that comes there about the importance and the history of the Resakas in the area. And so in the courtyard of this headquarters, there is a rain garden that is flooded periodically from the rainwater that's captured, and it completely mimics the Resaka environment. Birds come there, butterflies, it's an amazing thing to see, and a great example of how you can actually repair the land that you build on.
And here's our question. A project is in an infill location in the downtown of a large city on a previously developed site. The design team should consider which of the following. This question requires that you go a little bit beyond the credit requirements, so we're asking you to tie in several concepts here. So take a few more seconds, jot down your responses, and then we'll talk about them. Well, the correct answers are 2 and 3, so provide native adapted vegetation in accordance with restored habitat, and use a combination of strategies to improve rainwater management. Now this sample question, as I mentioned, is a little more broad than the ones we've seen so far, and it relates several concepts, including what it means to be an infill project in a major downtown area, where in this case it's unlikely that there would be undeveloped parcels, especially on an infill site, and it's unlikely there will be existing natural rain flow patterns. And our next credit is SS credit heat island reduction. Our intent is to minimize effects on microclimates and human and wildlife habitats by reducing heat islands. There are 2 ways to approach this credit. First off, the project needs to install compliant roof and non-roof measures, and we'll talk about what's compliant here in just a second, for 50% of non-roof area and 75% of roof area, and that's based on a weighted average calculation. So if you were a little under on one, you can make up the difference with the other. Now, option 2 requires that at least 75% of parking spaces be under appropriate cover. Now, when we talk about qualifying non-roof areas, what we really mean is shaded. Now, there's a handful of ways that a non-roof area can be shaded, according to LEED. It can be provided shade vegetation. It can also be provided shade by other man-made elements that have at least a 0.28 3-year aged solar reflectance value. And we'll define that here in a second. The final way is it can be open grid paving. So we saw that in a recent example, and here's where it can directly contribute LEED points. Now on the roof side of things, there's really 3 types of roofs. There's low sloped roofs, which are less than 2 to 12 rise. There's steep sloped roofs, which are more than 2 inches per foot of a rise. And then there's vegetated. Now, on the vegetated side, that's pretty easy for this credit. It complies outright. Now, for low-sloped roofs, there's two requirements here. There's an initial SRI, or solar reflectance index value. There's also a 3-year aged SRI. So for low-sloped roofs, the initial SRI must be 82, and the 3-year aged SRI needs to be 64. Now those are minimums, so it can easily be more than that, and that's okay too. For steep-sloped roofs, the requirements are much less stringent. It only needs to meet an initial SRI of 39, and the 3-year SRI just needs to hit the 32 mark. So in terms of strategies, first of all, consider installing either a high albedo or high reflectance or a vegetated roof. These reduce heat absorption. Now for projects pursuing the roof and non-roof measures compliance path here, or option 1, there is an opportunity if there's no 3-year age solar reflectance values. Now this is a new term in LEED, so the 3-year age solar reflectance is not something that LEED has required from projects in the past, and it stands to reason that a lot of the roofing manufacturers out there may not have 3-year age data available yet for their products. And this represents a workaround, so it wouldn't preclude projects from using roofing materials that didn't have that 3-year age data as long as they meet the initial. Now we talked about heat island effect, but I want to define it here so everybody's on the same page. Is the thermal absorption by hardscapes, such as dark non-reflective pavement and buildings, and its subsequent radiation to surrounding areas. Other contributing factors may include vehicle exhaust, air conditioners, and street equipment. Tall buildings and narrow streets reduce airflow and exacerbate this effect. So here we have an aerial view of the same project we've been looking at, and now we're talking about roof and non-roof areas. So first off, the steep sloped roofs have an initial SRI of 55 and a 3-year aged SRI of 52. This exceeds the requirements of 39 and 32 respectively. Now the flat roof area has an initial SRI of 99 with a 3-year age value of 92. Again, this exceeds the thresholds, which are higher for flat roof areas and are 82 and 64 respectively. And finally, we have the vegetated or green roof, and because there is no need to quantify the SRI of this, we know immediately that this qualifies outright. So this tells us right away that 100% of the roof area is going to comply. We also take a look at the non-roof areas. So we have the concrete pavement, the concrete flatwork, gravel paved pavers, and then some flagstone hardscape area. Once this is all tallied, it's over 92% compliant in terms of non-roof areas. So because we're over 50% here, and we're over 75% on the roof side, in fact we're way over on both fronts, we know that the project will meet those requirements. And here's our question. The design team wants to use a concrete parking lot with an integral color added to it. In order for this area to qualify for SS credit heat island reduction, which is true? And the correct answer is number 3. The initial SRI of the material must be 32 or greater. And our next credit in the category, SS credit light pollution reduction. And this one's very near and dear to me. The intent is to increase night sky access, improve nighttime visibility, and reduce the consequences of development for wildlife and people. Now there's really 3 stages to these requirements, although stage 2, as we'll talk about here in a minute, is pretty robust. So first, the project team needs to classify the lighting zone. We'll look at those definitions in a moment. They then need to meet the uplight and separately the light trespass requirements using option 1 and or option 2. And then finally, there's a requirement for internally illuminated signage that it not exceed 200 nits at night and 2,000 during the day. So regarding point 2, here we start to look at the actual requirements. So there's 2 options for both uplight, and there's also 2 options for light trespass. Now the first option, actually for both, but we're talking about uplight here, is the BUG rating method. And BUG is an acronym standing for backlight, uplight, glare. What this requires is that the project use only fixtures that have been rated for low uplight contribution. Now, these luminaire uplight ratings are listed on many leading luminaire manufacturers' products. So if you go into your lighting store, you may find these ratings simply listed on the box, or it may be included in supplemental product literature. But many leading manufacturers today are reporting these uplight ratings. And if you can meet those depending on your lighting zone, you'll automatically comply with the uplight criteria. Now the next way to approach this is by using a calculation method. So this throws those prescriptive criteria out the window and then focuses on a percentage of light that's emitted at 90 degrees, so basically the horizontal plane or higher. And now the thresholds are really aggressive for the first two lighting zones. They allow 0 light from horizontal on up. In an LZ2 you get 1.5%, LZ3 doubles that, and LZ4 doubles again. Now again with light trespass there's two ways to do this. Option 1 is also the bug method. But this, instead of looking at the uplight rating of these fixtures, it looks at the backlight rating and the glare rating, and then matches those up with the corresponding lighting zone and determines if the project is prescriptively compliant. The next way is rather time intensive, or can be for projects, and requires completing a photometric site plan so that you know the light levels along your site boundary. Now, the thresholds are here very aggressive, so 0.05 foot candles at the project boundary or at the lighting boundary for MLO lighting zone 0 and 1, only 0.1 foot candles at LZ2, 0.2 at LZ3, and then 0.6, which looks like a lot compared to 0.05, but is still only a very small amount of light. Now we talked about light pollution, but I want to take a moment to define this here, because for anybody that's not very familiar with these concepts, it can be kind of a foreign idea. Light, if you turn it off, it immediately stops. There's no residuals, no physical residuals from light in terms of pollution. But this is waste light from building sites that produces glare, is directed upward to the sky, or is directed off the site. Waste light does not increase nighttime safety, utility, or security, and needlessly consumes energy. We have a lot of strategies here. Now, before we jump into the rest of these, I want to say a few words about the lighting boundary. In many cases, this is identical to the LEED project boundary, which we talked about in terms of the minimum program requirements and also in the introduction section where we talked about the boundary. And now the default lighting boundary would be the LEED project boundary, but in certain instances that can actually be pushed out a little bit. So say you've got a 0 lot line project that has a public sidewalk immediately abutting the building. It is acceptable to extend the lighting boundary, not the LEED project boundary, but the lighting boundary to the end of that sidewalk, or to the exterior portion of the sidewalk where it meets the street. So you have a little bit more flexibility in how you define this lighting boundary, because it doesn't always make sense to align completely with the LEED project boundary. Now, maintaining safety is really one of the primary functions of nighttime lighting. Many people would say it's the primary function. Now, while it's very, very important to maintain safe light levels, what people accept as a safe light level varies quite a bit. It, in many cases, boils down to maintaining uniformity across the site. So you don't have a bright spot right next to a dark spot, because it's really the eyes in terms of what they can see in those dark areas that's going to determine if it's a safe location or if it's an unsafe location. Minimizing site lighting. Now that's a great strategy, and using the computer software so that you model that lighting and understand exactly where you're putting the light on the site. So you don't, well, we talked about uniformity already, so you avoid uniformity issues, but you're also able to scale back your lighting system if you're providing more light than you actually need. Now, we talked about the two options for backlight and glare, and then separately the two options for uplight. Now, uplight and light trespass requirements, they're really separate here. So we have the uplight requirements on one hand, which you can select the bug method or the calculation method, and then separately we have the light trespass requirements, which you can very similarly select the bug method or the calculation method. Now, while many projects will either select the bug method for both or the calculation method for both, it is acceptable to select the bug method for one and the calculation method for the other. There's also a handful of lighting types that are exempted here. There's a handful of reasons, but really it would be difficult to model these effectively, and there's some appropriate exemptions here where really safety must remain paramount. Now, some lighting is exempt. First of all, we have specialized signal or directional marker lighting. We also have facade lighting only in those brighter MLO lighting zones, of course, as long as it's turned off between midnight and 6 a.m. We also exempt any theatrical or stage or film lighting, any government-mandated roadway lighting, hospital emergency departments, including helipads. I think that one's pretty self-explanatory why that would be exempt. We can light the national flag in MLO zones 2, 3, or 4, and any internally illuminated signage, because there's a separate requirement that addresses that directly. Now here's the definition of the BUG rating, a luminaire classification system that classifies luminaires being light fixtures, in terms of backlight, uplight, and glare. BUG ratings supersede the former cutoff ratings. So here we look at the specific definition of these lighting zones. We have LZ0 through LZ4, and these correspond with an increasing amount of ambient illumination, or to put it another way, they have a higher level of nighttime brightness. Now the criteria here are pretty descriptive and give a lot of examples of what types of locations would qualify under different zone designations. But I wanted to say a quick word about LZ4. In fact, Times Square is the only LZ4 location in the United States. So while there are other locations meeting this classification in many countries around the world, the LZ4 classification is truly reserved only for projects located in these extremely bright locations. And here's our question. Reducing the amount of light that leaves the project site at nighttime results in what? And the correct answers are 2 and 4, more visible stars and safer migrations for birds. Now, there's a handful of credits that are in the building design and construction rating system. However, they don't apply to the LEED for new construction and major renovations rating system adaptation. So the credits and prerequisite here, first of all, we have environmental site assessment. This applies just to the LEED for schools and LEED for healthcare projects, where the intent is to protect the health of vulnerable populations by ensuring that the site is assessed for environmental contamination and that any environmental contamination has been remediated. For schools projects, there's also another credit for master plan. This ensures that the sustainable site benefits achieved by the project continue regardless of future changes in programs or demographics. Now, LEED for Core and Shell has a credit for tenant design and construction guidelines, which educates tenants in implementing sustainable design and construction features in their tenant improvement build-outs. And then LEED for Healthcare has 2 dedicated credits here, places of respite and direct exterior access. The intent is to provide patients, staff, and visitors with the health benefits of the natural environment by creating outdoor places of respite on the healthcare campus. And for direct exterior access, again a healthcare-only credit, we want to provide patients and staff with the health benefits associated with direct access to the natural environment.